Hi, my name is Naya Patel. My student ID is 1014163336, and hereby I am presenting you my assignment 1 for COMP3132 Machine Learning. In this assignment, we are working with fashion MNIST. So let's start. We will start with importing the necessary libraries. Next up is our first question, which asks us the dimensions of train image, train label, test image, and test labels. So as you can see, here is our dimensions. Next up is what's the length of train label and test label. So here, as you can see, 60,000 is the length of training label, 10,000 is the length of testing label. Next question is to show some of the test and train labels. So we are showing first 10 labels. So as you can see, here is our output. Next question is to show the digital content of image at index 5 in training dataset. So let's see. So as we can see, here is the digital content of training image at index 5. Next question is to plot the image. So as you can see, here is the image. Next question is, what is the label for the index 5 in training label and what does it mean? So as we can see, the label for index 5 is 2 and it's called it is pull over. So as we can see, here are our labels, 10 labels, and the one with the label 2 is pull over. Next is asking us the digital content of the image index at 500 in testing dataset. So as we can see, here is our output. Next up is the same. We have to plot the 500 one. So here it is. Next up is we need to show the label for index 500 in test label and what does it mean. So as we can see, it's the same number 2 label and it's put over. Next up, we need to import models and layers from Keras library, which we have already imported in cell 1. The next, in here, I have combined 5 questions, which is question 1, 12, 14, 15, and 16. So it asks us to define a subsequential model and call it my network. So as we can see here, we have defined it. Next up is we need to reshape the images from 28 by 28 to column with 784 neurons. So here we have used flatten for that. Next up is we have to add one hidden layer that has 512 neurons. So here it is. Next, we need to add another layer which has 128 neurons. And here we did that one as well. And next up, we have to add one more layer with 10 neurons using the softmax as the activation function. So here it is. Let's run this cell. And as we can see, here is our output. Next up, we have to normalize the image by dividing the image by 255. So by running this, here is our output which we are looking for. Next up is compile the model using two settings and compare the results. So there are two different settings which are given for us. One is option A, which is compile using Adam optimizer, and the other one is option B, which is compile using RMS prob optimizer. Here as well, I have combined two questions, question 17 and question 18. And in the 18, it's asking us after compilation, find the pattern using fit command and set the number of epochs to 10. So here is our code for that. Let's run this. This will just take a while to load. Can run this one as well meantime. So while this are running, I'll explain the next question. Like we need to compare fashion MNIST and MNIST. So the main difference between them is one is more complicated, the other one is more simpler one. So fashion MNIST is a dataset which is advanced alternative to MNIST dataset. So in the MNIST dataset, there's a handwritten digits, while the fashion MNISTs have like different images of clothing items. So while both of them has 60,000 training images and 10,000 test images, but they differentiate in terms of complexity. So MNIST dataset comprises of grayscale images of digit from 0 to 9, making it simpler, while MNIST contains images of various clothing items such as t-shirts, trousers, which is like more complex patterns and textures. And as we can see, it's still running. So then I'll explain the next question, which is what we can interfere from differences in accuracy. What could be the reason for that? So there's not much difference. The difference which we can usually get it is depending on the complexity of the data set. So MNIST achieves a higher accuracy compared to fashion MNIST. The reason is the complexity. So the both of them have images in them, but as MNIST has handwritten digits, it is much simpler and well designed shaped, while fashion MNIST have t-shirt, shoes, which is like more complicated, so it's like hard for to distinguish. So another reason could be the difficulty in distinguishing, like how we can distinguish them. So as we know that MNIST have digits like 2 3, so they have like distinct structural differences, which makes it easier to classify, while fashion MNIST they have like t-shirts and shirts which have similar outlines, so it is much difficult to differentiate them. So you can see this one is successful and the next one is still running. As you can see, this one is successful. And our last question is use the evaluate function from the Keras library to calculate the achieved accuracy and loss over the test images and labels. So let's run this. And as you can see, our test accuracy is 88% and loss is 0.5%, 0.5. So over here, we can see there's no overfitting as there's not much difference in both the accuracies. And that's pretty much for my assignment 1. Thank you.